everyone, this is Miss Cave with a lesson on translations. We learned today that a translation, if we look at these two letters in the middle of the word, the SL, it will help us remember that a translation is a slide. A translation is a slide, and a slide can be horizontal, which is left to right, or a slide can be vertical, which is up and down. And perhaps I should say and or, because we can have a combination of both. We can have a translation that is both a horizontal slide as well as a vertical slide. We can have both of them. So today what we're going to do is to learn how to translate shapes, quadrilaterals and triangles on the coordinate grid. So we're going to look first from a graph. So we're going to turn our foldable and we're going to look at an example on the graph. And then we're also going to look at how we can use changing X and changing Y, so using algebra to translate shapes on the grid. So let's start with our first example. The figure below shows triangle HJK. We're going to graph the image after a translation of 5 units to the right. And if it's to the right, I want us to go ahead and get in the habit of recognizing that to the right would be horizontal. So write that down, horizontal. And it's 2 units down, that's vertical. All right, so horizontal to the right is going to be 5 units to the right, and 2 units down is going to be 2 units down. So the way that you do this when you're translating an entire shape, just like we were translating our bodies, you're going to do 1 point at a time. So you're not just going to translate the entire shape, you're going to take one of the points and translate them one at a time. So I'm going to take first my J, and I'm going to translate it 5 to the right. I'm going to count 1, 2, 3, 4, 5, and 2 units down. I'm going to count 2, 1, 2, and then I'm going to plot my point. So again, 1, 2, 3, 4, 5, 1, 2. And then for J, so that I know that this is a new J, it's not the original, it's actually an image of the original, I'm going to put this little prime symbol. This means prime. That's how I know it's a copy of the original and I can tell what the original shape is. So now I've translated 1 point. I'm just going to go forward and do the other 2. So now I'm going to go to H, and again I'm translating 5 to the right, 2 down. So I'm going to translate 1, 2, 3, 4, 5, 1, 2. And so look, it lands right on the y-axis. And then this is going to be H prime. So we've got 2 points so far. Now we're going to take K, our third coordinate, and we're going to do the same thing. We're going to go 5 to the right and 2 down. 1, 2, 3, 4, 5, down 2, 1, 2. And that's going to be K prime. Now once you've moved each of the points, then you can connect them to form your shape. And what you should notice about the new shape, the image, is it's always congruent. So the image is always congruent to the original. If it looks different, if it looks bigger or smaller, or the side links don't look like they're in the same proportion, go back and check, because it should look exactly the same. The image, which is the new shape, is always congruent to the original shape. And so you notice here we had a translation. We had 2 things happening. We had 5 units to the right and 2 vertical units down. All right, now that we've looked at a triangle, our second shape is a quadrilateral. So So I'm just going to move over here, fold my paper a little bit so we can see it. So example 2, it shows quadrilateral ABCD. We're going to graph it after a translation of 3 to the left and 4 units up. So to the left, again, is going to be horizontal. And since it's going to the left, it's going to be -3 horizontal, because we're going to the left. And it's going to be 4 units up, so it's going to be +4 vertically. All right, just putting in that vocabulary, because you'll either see left and right, up and down, or you may see horizontal and vertical. And if we look at this shape, what shape does this appear to be? A rectangle. Good. A rectangle is also a what? Parallelogram, quadrilateral. Good. All right. So now that we know what we're going to do, we're going to go ahead and do it. So I'm going to take each of my points, starting with A. I'm going to go 3 horizontal. So I'm going to count 1, 2, 3 horizontal, and I'm going to go up 4 vertical. 1, 2, 3, 4. And I'm going to name that A prime. I'm going to do the same for B. I'm going to move 3 to the left. 1, 2, 3, and I'm going to go up 4 vertically. 1, 2, 3, 4. It's right about where that arrow is. And that's going to be B prime. I'm going to continue with C and D. C again, 3 horizontal. 1, 2, 3. And 4 vertical. 1, 2, 3, 4. And that's going to be C prime. And then finally my D, I'm going to go 3 horizontal. 1, 2, 3. And I'm going to go 4 vertical. 1, 2, 3, 4. And you can see that the new shape actually overlaps the original. And that's okay. That's going to happen. Then we connect our points. I'm going to double check these, because 1, 2, 3, 1, 2, 3, 4, 1, let's see, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay, good. And then I'm going to connect them, and it should form a congruent rectangle, and it does. Any questions so far on translating shapes? The big idea with this is to always translate one point at a time. Don't try to translate the whole shape, because that's when those errors are going to happen. You're having to count on a grid. Don't try to translate one point and then move all the other ones over. Do one at a time. Okay, so on the bottom, it has us using algebra, and I'm going to connect the algebra for you. And I'm going to also see if we can do this on the grid at the same time. So let's look at example 3. So we're going to go to example 3, which is right below the first example. So example 3 says triangle DEF has vertices 3, 1, 5, 6, and F 5, 1, 5, -1. Find the vertices after a translation, 7 units left and 3 units down. Okay, so what we're going to do is we're going to go ahead and make that shape on the graph above so that you guys can see the connection. So I'm going to make the shape, so I'm going to need a different color because it might overlap. So I have 3, 1. See what I'm doing? I'm just taking these original vertices and I'm going to use the graph I have up here to do it. So I'm going to take 3, 1. I'm going to label that D. 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm going to label that E. And then 5, -1. 1, 2, 3, 4, 5, -1. I went down 1. So that's F. So here is the original shape. You're doing a different one this time. I just want to use the graph so that we can still plot it. So you're plotting that same shape using these coordinates here on that grid. And we're going to look at how we can use rules. We can just change our x and y values to come up with the new coordinates. So the vertice of D, our original D, is 3, 1. Okay? And so what we're going to do is we're going to go 7 to the left, and we're going to go 3 down. So we're going to change 7 to the left and 3 down. So I'm going to take D, and I'm going to count 7 to the left, 1, 2, 3, 4, 5, 6, 7, and I'm then going to go 3 down. 1, 2, 3. See that? So that's now D prime. I just took the D, I went 7 to the left, 3 down, and plotted my point. And now what I'm going to do is, before we write the rule, and I'm going to teach you how to do that, we're going to look at the new vertices of D, or the new coordinate of D, D prime. So D prime, our D original was 3, 1. D prime is -1, -2, -3, -4, -2. Okay. Let's do the same thing with E. I'm going to take E. I'm going to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. And I'm going to go 3 down. 1, 2, 3. Right here, that's my E value. And so my original E was 5, 6. And my new E value was -2, 3. All right. Now we're going to go with that third point, which is F. So my original F was 5, -1. 5, -1. And I'm going to translate it 7 to the left. 7 to the left. 1, 2, 3, 4, 5, 6, 7, and 3 down. 1, 2, 3. So that's F. So now I'm going to connect it. And then I have, look, it looks the same as my original. It's just been slid across the grid. It went over to the left and down. So my original F was 5, -1. And my F prime is going to be -2, -5. So again, the coordinates are -2, -4. Okay, so now we're going to get to the middle part where we're looking at rules. So the rule for this, okay, so I want you to look, if we're changing 7 to the left, what value is changing, the X or the Y? What goes left to right, X or Y? X. So what's changing is X is being decreased by 7. And then notice when we go down 3, up and down, what value would be changing? Our vertical, would that be X or Y? Y. So look at, this is what the rule is right here. It's that simple. So if you look at 3 and then you look at -4 in our D value, I went from 3 to -4, so I went down how many? 7, -7. The 1 to the -2, I went, I'm sorry, let's go back to here. I didn't go down, I went to the left 7. So 3 minus 7 is -4, but the number went down. And then in the Y value, if I'm going from 1 to -2, I'm going down by what? -3. So the way I write a rule for this is X comma Y, just like this, write it on the line. And then you write X minus 7 comma Y minus 3. That's the rule. So you may see it that way. If you see x minus 7, that just means you're taking 7 away from your x value. And y minus 3 means you're taking 3 away from your y value. So 7 away from your x, 3 away from your y. Your rule is going to be the same for all of these, so let's just practice writing it. So it's x comma y. This arrow means you're changing it. It's changing by taking 7 away from the x and 3 away from the y. Same thing with the last one, same rule. And look at it, 5 minus 7 is negative 2. 6 minus 3 is positive 3. So we can say left to right, up and down. We can say horizontally, positive or negative, vertically, up or down, or vertically, positive or negative. And we can also use our algebra, what we know about changing y and changing x, and putting that into kind of like a formula. It's a rule. But it's the same rule. It needs to be the same rule for a translation because your changes should be the same for each of your coordinates. So we're going to try the next one without graphing it. So let's go to example 4. You've got your original vertices here. M is negative 2, 1. N is 3, 1. P is 2, negative 2. And I'm just recording these coordinates here, the original. And then Q is negative 3, negative 2. And so what it tells us here is we're going 3 to the right and 6 down. So if I'm going 3 to the right, my x is going to increase by how much? Yeah, so it's going to be x plus 3. And if I'm going 6 units up, what's happening to my y value? Y plus 6, okay? So my rule for all of these, and we're just going to put this here because it's the same, is x comma y. We use an arrow to show that we're going to make a change, and it's x plus 3 comma y plus 6. So what makes this so easy is we don't necessarily have to plot it at this point. We can just add numbers, add 3 to our x and y to our 6 to get our new values. So m prime is going to be negative 2 plus 3. What's negative 2 plus 3? 1. And then 1 plus 6. What's 1 plus 6? 7. Okay. N prime, we're going to do the same thing. We're going to take the x and add 3. What's 3 plus 3? 6. And then we're going to take our y and add 6. What's 1 plus 6? 7. Our p is 2, negative 2. So our p prime, we're going to add 3 to 2. If I add 3 to 2, what do I get? 5. And then negative 2 plus 6 is 4. And then our final coordinate here, we have q, which was negative 3, negative 2. So q prime is going to be negative 3 plus 3, which is 0, and negative 2 plus 6, which is 4. Okay? So we've looked at, and we could plot this on our graph if we had time, and we could double check to make sure that these are two congruent shapes just on different locations on our coordinate grid. But we've looked at how we can do this on a graph, which we will be doing mostly on a graph. But you're going to be able to graph from a rule. So I may give you a rule and ask you to come up with a graph for a translation. And that's our lesson on translations for today.